let's just summarize the previous video on what is gravity. Remember, if in space you have an asteroid here and another asteroid here, this one has a mass of m1, this one has a mass of m2. Now, because they both have masses, for some reason they will get pulled towards each other. So that's what gravity is. When a body has a mass and this one has a mass, the two will get pulled together. Um, if in effect you and the Earth are floating in space, in effect. So let's have a look at this here. The Earth here and you here. Well, the Earth has a mass of m1. You have a mass of m2. In this case, the m1 is much bigger than m2. So you and the Earth, or you and the Earth, will get attracted to each other. Remember, in effect, the Earth and you are in effect floating in space. You are actually floating in space here. It's just because gravity pull you and the Earth together. That's why it seems like you. That's why you don't get you don't fall off the Earth. It's because gravity exists between you and the Earth. Because you have a mass, the Earth has a mass. There's a famous formula: F equals a number here, m1 m2 over r squared. This number is just a constant. What that means is it's like pi. It's just a number. Okay. This is actually a famous formula. When you're older, you will fully understand this. But for the time being, let's forget about this and just have a look at this bit here. Now, gravity is related to this whole thing here. Okay, the higher the higher the overall number here, the bigger gravity is. If the overall number here is small, then gravity is small. So, for example, if you remember this, m1 times m2 divided by r squared. Hang on. If you look at the hang on. If you look at Earth here and the Moon here, okay, you are standing here, and the identical you standing on the Moon, okay. The Moon. Let's say the Moon has let's say it has a mass of 20 kilograms. Let's say it's silly, I know, but let's just say the Earth has a mass of, let's say, 100 kilograms, and let's say you have a mass of 2 kilograms. Up here is also 2 kilograms. Now, if you want to look at the gravity of you on the Moon compared to you on the Earth, well, get this number. Well, first thing you do, write down the formula. This one here, m1. Look at this bit here, okay? For you, for the Moon system, you will be 2 kilograms times the Moon, which is 20, divided by the distance. We will need to take the distance into account. So the distance between you and the Moon, let's say 10. Okay, the distance between here, the center of the Earth and the center of you, let's say 50. Okay, now then you divide it. So for the Moon system here, you on the Moon, which is 2, the Moon here, which is m2 here, is 20, and then you've got to divide it by this squared. So it would be 10 squared. Okay, this number here it's an indication of gravity. Okay. Now, if you look at this system here, the Earth here, it would be 2 times this number here, because m1 times m2, which is 100. And then you've got to divide it by 50 squared here. Okay. If you get a calculator and work this whole number out and this whole number out here, this system here is bigger than this system here. So what that means is gravity on Earth is bigger than gravity on the Moon. It's because the mass of the moon is smaller, so the gravity is weaker. If you look at this system here, hang on. Now let's say you are standing on the moon. There is a gravitational pull between you and the Earth, even though you're standing on the moon. So the question is do you get pulled to the Earth or do you get pulled to the moon? Now, okay, let's put some values in here. Let's say the moon weighs 20, the Earth weighs 100. Okay, I know it's silly, but let's just say that. You weigh, let's say, 2 kilograms. The distance on the moon, between the center of the moon and you, is 100. The distance between Earth and you on the moon is 300. So let's have a look at this. M1 M2 over R squared. Okay. Now let's look at the you and the moon. Okay. So it would be 2 times the mass of the moon now, which is 20. Okay. Look at this formula here. M1 is 2. M2 is the moon. Okay. Divided by the distance or the center of the moon to you, which is 10, and then we've got to square it. Okay. So now we are comparing the you and the moon. Now on this side we are comparing you and the gravitational pull of the Earth. So let's say you here. Now we are looking at the Earth. Okay, we are comparing you and the Earth now. So this is you, 2 kilograms. The Earth happens to be 100. Okay, divided by the now the R between the center of the Earth and you will be 300, and then we've got to square it. Okay, so now is this gravitational pull greater than this one here? Now, if the gravitational pull of the Earth, if this bubble here is bigger than this bubble here, you will get you're going to float to Earth rather than staying on the moon. If this bubble here is bigger, then you will get pulled to the moon and not to the Earth. Okay, so let's work this out. So this one will become, hang on, it will become 200 over 300 squared, and then this one here will become 40. Remember, 2 times 20 is 40 over 100. Over 10 squared. Remember, the 10 is much smaller because it's nearer to the moon. You are actually nearer to the moon compared to the 300. You and the Earth. Okay. So now this whole bubble now becomes hang on, let's see, 200 over 9. 300 squared is like 300 times 300. So I'm just going to get 3 times 3, which is 9, and I've got 4 zeros. 1, 2, 1, 2. Okay. On this side, it will, remember, you and the moon will be this become 10 squared is 10 times 10, which is 100. Okay. Now remember, we are comparing the two here. Let's divide top and bottom here by 10. So that would be this. Okay. We just want to know which is a bigger number of the two. I'm going to divide top and bottom here by 100. Okay. Let's just simplify it. So this will be 2, and this will be, let's get rid of this. So it's actually 900 here. Okay. Let's get a calculator out and let's divide this. Hang on. Calculator. Okay. 2 divided by 900. 2 divided by 900 equals let's say 0.002. On this one, 4 divided by 10 is 0.4. I know these figures are silly, but the point is this number here is stronger than this number here. So in effect, the gravity here is bigger than the gravity pulling you to the earth. So remember our system's like this. You are on the moon here. Between you and the moon this is an indication of gravity. It's bigger than you and the earth here. You and the earth is really weak. So you would get pulled to the moon and not the earth. Okay?